I'm going to give you a tour of the Croquet Microverse platform. We're starting with two users side by side. This one, as I move forward, you can see the white rabbit, turn him around, and of course, he sees the other user, the Mad Hatter. Both of these users can move independently and interact with the world, of course. But what I want to do is go into what we call presentation mode. And presentation mode basically allows me to give the other user a tour, but it has also the advantage of being able to demonstrate the two worlds side by side perfectly synchronized. This is not screen sharing. We're literally replicating the events on both sides, and so one user is basically towing the other around. So as this user moves around on the right-hand side, the other user moves in just the same way. Every object inside of Croquet is a kind of card. The idea came from HyperCard, probably more than anything. And the idea is a card is any kind of object. We'll show you a number of flat cards to start, but cards are extended with what we call behaviors, which are just a kind of JavaScript code. In this case, we have a little bouncing logo simulation. And a card, I can actually manipulate that. I'll grab this card and move it around. You can see it's actually a 3D object. And you can see that anything I do on the right-hand side, I can do on the left. And I can actually modify the simulation. I can drag that logo dynamically, moving it left and right, up and down. What's wonderful is it's so easy to do this. Programming this little bouncing logo is trivial, and the synchronization is literally done for you. Actually, let's switch over to the other side. I can drag it on the left-hand side, and it's updated on the right, just as you'd expect. Let's keep going over to our right here. We actually have a PDF viewer. And this works just as you'd expect. I can scroll through it up and down. And of course, it's also perfectly synchronized. If I click on it, I can jump from one page to the next, as you might expect. It also can be manipulated. I can pick it up and move it around. Over here, we have a text editor. And I just click in there and I can start typing. This is Croquet. But one of the things that should be noted is, unlike CRDTs or operational transforms, this is instantly updated. It doesn't require an eventual consistency model. It's always updated instantly, which is actually makes that kind of editor so much faster and feels so much better than what you'd find in systems that uses other approaches. This next card actually is what we call a deck of cards. In this case, we have a base card, that black card. It's grabbing live data from SFox, a Bitcoin vendor. And what it's doing is just grabbing that data and displaying it, but it's also publishing that value. In this case, we have two other cards on top of it. The first is a bar graph card. The bar graph is listening to those published values and graphing those dynamically. It doesn't know anything about Bitcoin. It just knows that it's part of this particular deck, and it's listening to sort of a generic value. It can be manipulated in just the same way. I can drag it and move it around. The other one is Bitcoin logo you see in the top left there, and it's listening to color changes. When the value goes up, like it just did, it goes green. When it goes down, just like it did, it goes red. And here, we're going to show you something extra special. This is a portal. We're opening up a portal to a completely different world, a completely different URL, in fact. And just like everything else, I'm looking literally through a portal. Like everything else, even portals or cards, I can grab this and move it around. I can spin it, move it out here. But basically, portals are implemented in what we call multiplane portals. Very, very similar to the way Disney did multiplane cameras when he created the movie Snow White. What we're looking at is stacked iframes. In fact, what I'm going to show you here is that stack right there. I'm going to switch it over to this one, and the reason for that is I can move this one around because the other one's following me. And you can see how that hole right here, is tracking, and then the transforms are being passed through. But that's all that's being passed through. I'm going to move it back so that we can kind of have a little more normalcy. And what we're going to do is walk through this portal together. So we're in a completely different world, a completely different URL, actually. It can be any URL, just like you can mix any iframes in a web page. Over here, we have ability to control this crane back and forth. Notice the robotic forklift down at the bottom here. We're going to walk down here, and we're going to open up this room. And inside this room, we actually have a number of very, very cool objects. First, notice that drone flying above right here. I'm going to tap it, and that pauses it. Tap it again, it goes again. Tap it again, and it stops. This is the actual code that's running that drone. I'm going to move it down a little bit. And you can kind of see what's going on here. We have is the setup basically adds an event listener, pointer down. And when the pointer down event, which is basically a mouse down in a 2D screen, or it might be a pointer in an AR or VR system, it'll call the toggle function. Toggle basically says if you're circling, stop circling, and if you're not circling, start. When it actually runs, it calls the step function, where it basically does a rotate by a little bit and move forward a little bit, which is how it runs around in a circle. But what I want to do is create a property sheet for that. And I'll move back a little bit here. And I want to take this. This property sheet describes the drone, including where it is, what its state is, basically every bit of information you need to recreate that. And what I'm going to do is duplicate it. And I'm going to duplicate it a number of times. And notice they're all going in that same circle. And just a few more. And then what I'm going to do is delete the original one because I don't need him anymore. And so we have these drones flying around. Now I could actually use this editor to modify the drone state, but the way we usually do live programming, and this Croquet is a live programming environment, is we use external tools like Visual Studio Code. So what I'm going to do is switch over and launch what we call a watch server. A watch server basically is watching the local version of a file, and when it gets updated, it will update it inside the actual working world. So I'm going to hit that. So we're launching the watch server. The second thing I want to do is I have to connect this world to that watch server. So I'm just doing that now. So now what this means is I'm able to modify code using, in my case, Visual Studio Code. So here's that same code that we were just looking at running. And if we look at this, it's the same thing. We have the event listener, and we have the step functions and the toggle. What I want to do is, first of all, let's just do this for fun. Let's do a comment. This is a comment. In fact, let's do something that's kind of visible enough. I'll do a couple lines here. And one on top because it looks silly without that. There. And then I'm going to compile this, or I'm going to save it. I'm not compiling it, but is immediately compiled here. Notice when I did that, it was updated inside of here. But let's do this. What we're doing is we went rotate by and move forward by. I'm going to modify that. Instead of moving forward, I want to make it go backwards. So I'm going to compile that. Or I'm going to save it. It gets compiled when it's loaded. And you notice now our drones have a completely different behavior. And actually, what's happening is they were running in a circle around each other, but when we reverse direction, they're doing outside circles now. And so they kind of go away from each other and then they converge. But if we look at this code here, we can see that that negative value was added. Just for fun, I'm going to switch it back. I'm going to wait till they get back to their center point. And then I'm going to compile this here. There, that's good enough. And now they're going basically around in that same circle. So it's a live programming environment, and that's one of the magical things about this system. So let's keep going. Over here, we have another live data feed. This is almost every commercial flight on the planet right now, within a few minutes, actually. These circles, these little dots, are an airplane in the sky right this moment. We get this data from OpenFlight, and you can see I can spin this, but you can also see that one of the things is the circles are so much bigger, the spheres are so much bigger than the airplane, they don't move very fast. If you watch it long enough, you'll actually see them move. But I want to show you something here. You can see that we're looking at Europe. Let me back up a little bit, and I'll move this down just a bit. We're looking at Europe here, and you can see to the east, that's Europe, and we have this big open area, and obviously, I mean, to the west is Europe, and to the east is Moscow. This big open area where there are no commercial flights is Ukraine, or actually probably well beyond Ukraine. And it's no surprise that that would be the case there. But let's keep going. I want to show you something that really shows off why Croquet is such a powerful platform. We have this physics simulation running here. And what I'm going to do, you see this little cube here. I'm going to click on it, and it jumps up into the air. Notice it's perfectly synchronized. I'm going to put this up here, stack it here. One of the things to notice is that we're emitting the same object on both sides, although it's completely random object and random color. We're actually using a replicated random number generator. But what's magic about it is we don't have to share that information. When you have a replicated system like this, even the randoms are computed independently, so you don't have to share that information remotely. And basically right now, aside from a timestamp value coming every so often, we're not exchanging any information about the state of these worlds. The simulations are running bit identical, and we're able to see that. And so what that means is the bandwidth required to maintain this perfectly synchronized simulation is really near zero. The reason I did this is I wanted to show you how we can just throw these up in the air and everything is synchronized like that. And now we've got a bunch of cubes here. I can just sort of click on those, and notice those are also perfectly synchronized as we jump up. Everything's live, everything's synchronized. This allows for a very, very different kind of interaction. We think of Croquet as primarily a communication platform where I see what you see and you see what I'm doing as I do it. As I lift this up on this side, or I can switch over, and of course it's perfectly symmetrical on both sides. So we're actually able to share even very, very complex interactions and simulations. That is Croquet.